The Panten Pro Vitamin, as we say in German bottles, are not very complicated, but they're good study objects, and they have a very similar approach to how they created those orange colored shapes, as you can see on my computer model here. So this is kind of like what I would like to focus on inside this demo. So let's take a look at how I started. So again, as you can see, I, for each object or each bottle, created myself some profiles. So I have a good understanding of how things have to look like. So here I have a very simple vessel. So you see the cross sections extruded down, filled, and then these edges are creased with a value of 1. And when we go to the subdivision surface modifier, you see that I use an additional surface, the orange one here, to trim that shape off. So how was I able to quickly get very close to the original design? So I carefully paid attention to how does the bottle look from the side, and for example, how does the center line arc out when it cuts, how far does it go inwards, what actually was the distance between these two endpoints, how high does it cut, and for example on this layer here, you can see that I have, for example, created this spline, which is actually pretty close to the outcome. I also have here kind of like this V that's also very close. But the problem is these outlines or profiles are in this case very hard to see, which is why, for example, I actually created myself this V as a big mesh. So why is that useful? Well, visibility wise, it is always there. So one could say, well, why don't you just draw yourself a V and then project it onto the bottle, then you just see it. True, but then when I cut something out of the bottle, then the projection also will change. And this is always kind of like a nice approach. You just stick it into the object, and via the color difference, you easily can identify where the resulting edges are, in case we would use this green surface and cut it out of the blue bottle. And then I created this orange part. As you can see, this is a very simple mesh. So 1, 2, 3, 4, 5, 6 points extruded 1, 2, 3 times up. And then you see I arced it a little bit. I scaled these points. For example, here further together along Y and closer together along X, till, for example, up here they're totally flat as a line. And that then basically creates that shape inside the negative space of the V I need to cut out of the blue part. So how did I figure out actually how to arc this orange part? Well, that's exactly where this green shape was instantly helpful for. You see there? Oh, doesn't match. So all I need to do now is move this one till, for example, it touches it. Same, for example, down here. So there, nope, it has to be somewhere there. So that's the way how I identified the exact position. And then we can turn this one on, maybe turn this one off. And there you see actually that the resulting orange surface is incredibly close actually to the green one. Up here this looks like a triangular shape. That's a limitation of the geometry because we work with polygons here and subdivision surfaces. But in Fusion that actually will not be an issue. So let's take a look actually at the next object here. So this is pretty much the same approach. As you can see here, there is the surface which I sculpted so that I pretty much got the result I wanted out of the bottle. You see actually that if I turn this one off a little bit, these points are very horizontally or on the same y-axis or x actually, sorry. So this actually helps me to flatten the surface a little bit, and then these midpoints are always pushed out more to simply arc that surface more, and that actually then creates kind of like this look. If you look from here, that it's a little bit flat and bellies out and gets flat to this edge again. So very simple. And also just so you really pay attention to it, you see that this orange object never really rests inside an object along the edges. So these edges are always cutting completely through my blue object. So you can see here this lower edge is outside my blue object. In case somebody would like to know how I got this orange material on it, that's actually this material from this plane, Boolean. And when I go to the bottle, you see here I have a second material. Let's say I remove this one. So I could maybe go to here and add a material and say material assign. Okay, so to this face I assigned actually that green material. Let's remove it for a moment. So that's a way how, for example, to one object you can add multiple materials and assign them to certain polygon faces. But let's say we make a new material and then there we load in the material slot. Not much happening. Well, what happens if we actually instead use the Boolean material and magically this shows up? So what's happening here? The thing is, everything that's orange right now, that's actually the geometry from this part. And it has this material. And that's the reason why now the Boolean material not being assigned to anything of the bottle will use the faces that come from this shape and texture it orange. That's a whole trick to it. Okay, so what's interesting with this bottle is also this arc and then how later this bottle actually got capped at the bottom. So I will Shift D, escape, make myself a copy, delete this one, remove this, and let's move it to there. Okay, maybe to here so I don't see the other one. So first thing you should know is actually this is a quarter object. So I have 1 point here, 1 point there, or a loop and a loop kind of get pole positions, which is why I can mirror it along the x and then this result along the y-axis. And then we just pass that into the subsurface modifier to make it nice and round. So that's basically how I did that trick. Very simple, not very complicated. But how did I get this really nice arc? Well, there are actually 3 ways how we could do it. Let's start with step 1. Now, because this is actually a quarter model, I only have to work with 4 points. So the highest, the lowest, and the 2 points in between. So for example, if I S0 scale this down together, I can move this one slightly down, and you see this also happens to this other part. Let's hide this for a moment. So very easy. Now I would have to move this one down, and then maybe this. This is too low. This is not necessarily very flat. Maybe a little bit higher. No, let me take there. And then we just kind of start maybe getting that shape. And you see, you have to just pay really close attention to move these points correctly, so you get a nice proportional arc. Totally doable, but it's also a little bit complicated. So let's keep it this way. What could be actually a second way? So I move this one over, and then I flatten this one, and I will actually apply the mirror modifier, and then at this position add my 3D cursor, add a plane, scale the plane down, add loop cut, Control R, 0, enter, and then I select only the outer lines, Shift E1, sharpen it, and then I can move this one down. So why did I do this? Well, we can add a subdivision modifier 3 and maybe call this one project target. Okay, so you might think class is going to use, no, class will use, let's use proper grammar, class will use the shrink wrap modifier, that's correct. So let's push this one on top, select this one, project, Z, this, okay. Class was able to just flatten it. Okay, so doesn't really work. But ever notice there's actually this vertex group? So vertex is a point. So there's actually a way to select only these points and add a group and then feed that into the vertex group, which currently is empty. So we go to the mesh data block, go to vertex groups, click the plus icon, and then click assign with these points selected. So you see select, could also select and remove, select, see they're gone. We could select those points and say assign, select, assign all, and maybe say this is the project group. Let's go back to the shrink wrap modifier and project group. Turn this one on. There it is. Perfect. So what is the advantage of this? Well, only with one point I actually adjust all these other points because I deform a surface, and I can actually create this nice arc on inside this object without going into edit mode. And I maintain my original design anyway, so this is a pretty nice interactive approach. Let me set this to wire for the moment and push this one really far down, and maybe those also really far down till we get this. So what's happening? When we go to edit mode here, you see this selected loop cut got pushed below this one, so we actually self-intersect the surface, so that doesn't really work well, which means that this point cannot go that deep. It has to remain at a certain height, and then everything will work out. But even here, for example, you see these are like really nice and smooth transitions. You can obviously do this by hand as well, but actually this process here is much faster. And the other advantage is I could Shift D, for example, select these 2 points, Control B and bevel it, and then zip, Shift E1, sharpen it, and maybe scale this apart a tick more. For example, this should be project target 2. So I can then simply say, show me the second one. No, I don't like it. Show me the first one. So you can have different variations actually saved as surfaces we project onto. So pretty awesome. So let's take a look at the third version, and that is called the proportional edit. We find this actually up here. So what does proportional edit mean? So if I press G now, you see there's actually a big ring around. If I move my mouse wheel, it gets bigger or smaller. And I make this one really big, and you see, hey, all these objects are moving. What's going on? Think about proportional edit like a magnet, and we can make the influence bigger and smaller, and it's like a sphere. And from the center to the outside, there is a fall off of different shapes. So let's go into edit mode, and I will select this point and this point. Press G and Z. Oh, I did not turn on proportional edit. GZ, and ooh, you see all these meshes move. So what does actually fall off mean? S, or the profile. Let's go random. It's like they all go random or constant, or all the same. Obviously linear, they're more like in a linear way. So think about, most times I use smoother, so there are like different curves, how the influence falls off to the edge of a sphere. But the problem you see is, everything gets adjusted. I do not want these points to be adjusted. Well, let's hide them. Then we select only these 2 points, move this one down, and let's adjust with our mouse wheel the influence till maybe the edge point just barely moves there. Alt H, and there you see everything is back. So hiding actually the geometry prevents it from being used. And what's nice about this one is you can see this actually has a nice smiley, see up, and this has a nice sad face or lips down. So what I mean, this is a really nice kind of like S shape that goes around the object. So this is actually a nice quick way also to get those shapes. The problem, however, is once you model it, you deformed the geometry. So which one do I use the most? If I really know how it has to look, then maybe this way. Otherwise, to be honest, I actually go with this command, because if at one point I need to finalize the points, I can always click apply, and then these points are actually baked into that position. So I can do it that way as well. So that's 3 ways how, for example, we could create this nice swooped arc on top. Let's take a look at how we can actually cap the bottom part of the bottle. And you see that, by the way, make sure you have proportional turned off. You see I always have quad faces all around, and even there I have quad faces. So how did I do this? Let's make a new circle, maybe 12 points, 0.1. So okay, then let's scale this for a moment so it looks similar. Maybe these points go in a little bit more. Let's add a subdivision surface modifier, zip zip, there. And no, actually what, I go up for the moment because it's easy to always show how it looks on the top. E and Z, there. Okay, so now how do I cap this? Cap F. Yeah, you might think, but as you can see, this creates really bad geometry, and you see kind of like lots of star points here. Fusion is not going to like you if you do this, so that doesn't work. So how can we now close this? So you see, I have actually a nice even amount of vertices, 12, which means I can select you and you, fill, you and you, fill, you and you, fill, you and you, fill. Oh, 3 points or 3 edges, fill. Nah, it's a triangle. We don't like triangles, so no. But I need 4 points to have actually a 4-sided face. So what we can do is Control R, click 0, enter. Now we have 4 points. I could, for example, fill this now. Yeah, it doesn't look too bad. But it gets a little bit pointy here. And that is because the distance between these 2 points, or the distance between these 2 edges, is much bigger than, for example, the distance between these 2 edges, and much bigger than between these 2 edges. So what we can do is, and that's why I had 12 points specifically, so I have those side vertices. I can take this point and snap it to there, this point, snap it to there, A, W, remove doubles, or T, tools, it's somewhere there, remove doubles. So now we have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, sounds like foxtrot. And the distances between this one and this one, this one and this one is much bigger, and I have a nicer transition. From here it's still a little bit flat. So what we can do is we select those points, move them up. Maybe also move this a little bit further up, because now I have 1, 2, 3, 4, 5 points. I can really sculpt a nice flat arc. If I would do everything with, let's say, a 6-point circle. Zip, zip. Come on. Okay, doesn't want to go so quick. There. Scale down. Actually have to rotate this one. Run R90. There. And subdivision surface. S and Y. Maybe this in a little bit. One more. A and then E and Z. Oh, 1 second. I just want to match them quite nicely. So one is there roughly, E and Z to there. Okay, so here the same, this edge and this, nope, this edge and this edge I can fill. Then I have 1, 2, 3. So Control R at the center. Then I have 4 points and 4 points. Then I can move this one up. Yeah, and there you also there you already see the issue is I face. I can't really pinch that edge as nicely as, for example, I did in that other design, or maybe with pinch I mean sculpt. So that's always the issue with the amount of subdivisions. The less subdivisions, the nicer and smoother corners, etc. are, but the less control you have to sculpt, and the more points you have, the more work it might be, but also the more details you could sculpt in. So that's pretty much everything that's important to understand. How many points do I always use? I never know. I have to guess object to object. That's the reason why I sometimes make those really quick test designs or test models to see if maybe an idea works out or does not work out. Yeah, okay. Oh, I forgot this one point. Zip. Control R, 180. Shade smooth and AA, Control N, zip. There we are. Okay, so that's pretty much how I built the bottom part. Now this goes to round in general. So for example, there, number 1 and number 2. There you can see that with this now I can also start flattening, for example, that side. Yep. So this is everything I wanted to show about those two bottles, how I created them using various approaches and techniques, for example, helping with those surfaces to understand where other surfaces should intersect my target bottle. You also notice actually that this is separated from the cap. So let me finish this video with a small tip. Whenever you do a model, it's not necessarily always that you build the final piece. Currently, I just want to quickly say, well, this cap maybe with this version, or this cap maybe with this bottle. So there's no point really to duplicate then those caps. I simply position everything so that maybe the cap, it's as it seems, perfectly sits inside the bottle. Because if I make a screenshot, you could not see actually that those are two separate objects. Obviously, when we make a final design and send it to a 3D printer, then we build everything together. But for the phase of exploring different designer ideas, steps you do not have to necessarily duplicate or do again, simply don't do. And like in this case, we just break the design up into separate objects, and then we can work on each object individually.